Welcome to Chem 327. This is experimental physical chemistry. And yes, phys chem is not just about equations and numbers. The theory you've been studying in the past 2 or 3 years have real consequences in the world and in your daily life. And in this course, we will explore those consequences and how to investigate them, and we will have fun. But first, let me introduce myself. I'm Professor Cynthia Go. And as you can see, I'm an experimental physical chemist. So of course, I'm biased in thinking that it's going to be fun. But let me try to convince you of that during the term. If I'm allowed to come in, my office is Lash Miller, room 522. But likely you'd have to be content with joining me online for office hours on Fridays at 2 p.m. or whenever you can find me on Discord. You can visit my website to learn more about my research interests, which centers on behavior at the nanoscale, and about my passion for developing technology for low-resource communities and for building science-based startup companies and mentoring students in these directions. If you want to email me, make sure you put Chem 327 on the subject line so it doesn't get lost in the tons of email that I get. But you can also direct message me on Discord, or for simple and general questions, I urge you to use the text channels on Discord. That way, your peers and TAs can help answer these questions quicker than I could get to them. This class is twice the size of the usual Chem 327 class, so I may be slower in responding. Now, we would like to get to know each of you well, but it may take some time to do so because there's 48 students in the course. So please help us get to know you. For starters, you may wish to introduce yourself in the Discord text channel. Well, tell us something that will make us remember you. And of course, you're welcome to talk to us throughout the term. And there'll be times when the TAs will ask you to come and interview you, and so will I. Now, this course is probably quite different than your previous courses. It is a lab course, yes, and you've had lab courses before, but we have no lab manual. Perhaps you think lab is where you pour chemicals or take data. Well, yes, we will have some of that, but much more. My goal is to introduce you to what I find fun about phys chem. That is being given a chance to design and implement a project that's of interest to you. And within that context, develop a variety of skills and some expertise in a small area of your choice. This is great fun. Perhaps for some of you, it's like doing science fair, but on steroids because you have potential access to more resources. Or perhaps it's a chance for you to explore, to ask questions, design a solution, invent something with help and guidance from the TAs and from me. But perhaps for some of you, it can be scary because you're fully responsible and there's no step-by-step procedure to follow anymore, but you'll get used to it. And don't worry, you have great TAs to guide your way. These TAs are PhD students in physical chemistry, and I chose them because they're good scientists and they're really interested in helping you learn. Note that they are there to provide you guidance and not to tell you what to do. You'll find that different TAs may suggest very different things, may answer your questions very differently. That's normal. They have different backgrounds, they have different interests. And what you'll learn is that you can consult many people and they may have different answers. And in the end, you have to develop judgment. We want you to have that. Okay, for something more mundane, here's how we have arranged this course. All lectures on Wednesdays will be held online in the Discord server called Chem 327 Cool Projects. If you go to Quirkus, you will get the link to this Discord server. If you haven't been to Discord before, I suggest you try it out. Just click on the link and it will guide you. And when you get into Discord, there's an introduction area that will introduce you to how, what we're going to be doing in that center. Discord will be serving, this Discord server will serve as our classroom. Now, the first 5 weeks of lab will also be done from remote on the Discord classroom. What I'd like you to do is pick up a lab kit from Lashmiller room 503. That's my research lab, and some of your TAs are there, on September 22 in the afternoon. And then every week for the first 5 weeks, you will join us on Discord during your lab hours. So it will be synchronous. You will be carrying out the work in wherever you are. The TAs and I will be there on Discord for consultation. We will ask you to talk to us. We're asking you to post your results or talk about them in the appropriate talk channels, and we will comment and suggest. And we also would like you to comment and suggest things on each other's work. Sorry, the PowerPoint presentation got ahead of me. Post your results, talk about them. We will comment on each other, give each other encouragement, suggestions, put up nice photos of your experiment. Our first experiment in particular is about contact angle. We'd like to see, we'll have a little competition about the results that you get. Now, you will be given some short videos to watch on certain weeks and some activities to do. And of course, the TAs will connect with you individually and later in teams to find out what you've done and to offer advice. As I said earlier, this is your chance to create and implement a project. The first half of the course is about giving you some skills and knowledge. After all, the only exposure you've had to non-synthetic labs may have been in first year, and then helping you come up with ideas. So the activities on the first part are designed for these goals. You have to finish all of them. Now, you'll be working on them individually from remote, but that's why you have to learn how to use Discord to discuss things with each other and with the TAs and with me, so we can advise you and we can help you plan and we can help you think. The second part of the course is what we call discovery labs, which we hope to do in person by then, and this will be done in teams. Now, if you want a detailed syllabus, it's posted in the Quarkus page, and I will also post it in Discord. So in the discovery labs, you will be working in teams. You carry out a small project with constant advice and suggestion, of course, from each of the TA. The TAs have office hours, and so do I. The planning from the discovery labs actually begins from the beginning of term. You have to start thinking about potential projects from the beginning, and a lot of our lectures and discussion will be about that. You should also talk in Discord to brainstorm with each other. Now, because of the current situation of having a large class in a pandemic, we will limit the types of projects that you're allowed to do. So you will have to get approval for the projects before you begin the project, and check your syllabus for when the deadlines are. You will have to source the materials for your project, and we will acquire them for you, but you have to tell us where they will be coming from. You have to understand that they have to arrive on time for you to be able to do the project. So the projects will be done in teams of 4, which you may, if you wish, you can subdivide them into 2 groups of 2, if that makes sense. Or sometimes some people even just divide the work into 4 different people. It's up to you. At the beginning this week, I will post a survey that we will ask you to answer, and we will take some of the responses that you have. We will take into consideration when assigning teams whenever possible. But nevertheless, your team will not be of your own choosing, but you have to learn to work together. Well, this is just a little taste of the real world. When you start a job, you don't know who you'll be working with. You still have to manage how to get things done. I do hope being in a team will mean that you will meet and make new friends. But if it turns out not, you still need to handle that relationship professionally. As part of your final report, you're asked to briefly describe each person's contribution, and a good team would have learned to partition work properly so that each member makes a good contribution. The weekly syllabus is out there, so just check it out. So here I've listed a bunch of learning outcomes that I hope will result from this course. They include things from more technical ones like acquiring certain skills, maybe using some instruments, and more professional ones like being able to work with others and managing a project schedule. I think these are all background needed by a good experimental physical chemist, but it also will be helpful in any future career that you have. Now, the marking scheme is in your syllabus. I will not go through it here. You will be earning marks for all and each of the activities throughout the term, so don't miss any of them. They all count. The penalty for lateness is steep, 5% per day, so it does not make sense to be late at all. Just do it on time, submit it on time. It's better than being late and trying to be perfect. Now, lastly, there are institutional policies that you should have known by now since you're all in your upper third or fourth year. But in case you missed them, they're attached at the end of the syllabus. You are here to learn. We are here to help you learn. You want a good mark? I want to give you a good mark, but you have to work and earn it. Do not plagiarize. Do not violate copyright. I expect all of you to have the highest level of academic integrity. And with that, let's have fun and have a good time in this course. I look forward to working with you as you make your discoveries, as you design your projects, and as you get on the path of experimental physical chemistry.